So we just talked about how the roots of a quadratic are solving a quadratic, and we have been factoring them. However, there's another way to solve quadratics, and that is by using square roots. And that is why we practiced square roots last week. All right, so this is section 9.3. I know we're jumping around a little bit, but it will all kind of start to pull together. So I'm actually going to go ahead, I'm going to start with example 1. We're going to jump right into examples. And I have x squared minus 25 is equal to 0. Now, option 1, of course, is that you could factor this, and you see that it's a ding-dong, or difference of squares. But the one thing I'd like you to go ahead and notice here is that when you have these two terms, so normally your quadratic looks like ax squared plus bx plus c. Now, this bx term does not exist. So there's no bx term. And that's what makes this so special. And when there's no bx term, you're going to go ahead and step number 1 is to isolate the square. And what I mean by that is kind of like when we isolated those absolute values, is that you're going to look for whatever's squared here. Now it turns out that the x squared is what's squared, and you're going to go ahead and you're going to isolate it. So what we need to do is that we need to add 25 to both sides, meaning that my equation is x squared is equal to 25. Now, you might be able to do this in your head, but we're going to show the steps with this. And that is that once you've isolated that square, you're going to go ahead and you are going to take the square root of both sides of the equation. And I'm going to underline both there, both sides of the equation. So we're going to take the square root of x squared, and that's because a square root undoes a square. And then you're also going to take the square root of the right side of your equation, or for us, 25. And that means that the square root of x squared leaves us with x, and the square root of 25 is 5. However, I want to show something super, super special, so go ahead, lock in here, is that it's a positive 5, but it's also a negative 5, and we do that by showing that little plus or minus sign. So last step is to add the plus or minus, so this little plus or minus sign, to your answer. And then if need be, you'd solve from there. So I'm going to say step 4 is continue solving for x. And that will make sense in a little bit. But for right now, we have x isolated. We know that x is equal to 5 and x is equal to negative 5. So I can go ahead, I can box this answer right here. And that's what that little plus or minus means, is that it's those two answers. So the two roots of it are 5 and negative 5. Okay, so let's try a few more of these. Example 2 with this one, it's going to have a little extra steps in terms of taking these square roots. So 3x squared minus 27 is equal to 0. So again, step number 1 is that I have to isolate that square. So I always think it's a good idea to go ahead and underline what's squared, kind of like we underlined that absolute value before, and that's that x squared, so I'm trying to isolate that. So I need to add 27 to both sides, leaving me with 3x squared is equal to 27. Now, you would think that it's isolated, but it's actually not, because it's being multiplied by 3. So you have to divide everything by 3, because only the x is the thing that's being squared. meaning that you have x squared is equal to 9. Okay, and now that your square is isolated, you're going to go ahead and take the square root of both sides. I'm going to write this in a little bit different way. Sometimes they just go ahead and write a whole square root sign over the entire equation. That's okay too. Meaning that my answers, x is equal to 3. Don't forget that plus or minus in there is that you have to have x is equal to positive or negative 3. All right, let's go ahead. Let's move on to example 4. Oh, excuse me. Example 3. Okay, so this one's going to look a little bit different. X minus 1 squared is equal to 81. All right, and here's what's kind of cool about this, is that this right here is what's being squared, meaning that your squared is isolated already. All right, so we can go ahead and we can actually take the square root of this side and the square root of this side. And this square root kind of cancel each other out, meaning that you are left with x minus 1 is equal to, now the square root of 81 is 9, but don't forget that you also have a plus or minus in there. And this is where, just like those absolute values that we used to do all the time, is that you're going to go ahead and you can set up these two equations. Now I'm going to show you right here, I'm going to have plus 1 and plus 1, meaning that x minus 1 is equal to, and we would have 1 plus, excuse me, x is equal to 1 plus 9, and x is equal to 1 minus 9, meaning that we would have x is equal to 10 and x is equal to negative 8. And the reason that I went ahead and simplified those was because we could. They were nice whole numbers, and they go ahead and your two roots are 10 and negative 8. These examples are going to get a little bit more complicated, but we are going to work through every single one of them. So we have 5x squared minus 35 is equal to 0. And the reason I'm going to use square roots on this one is because we don't have that middle term, we don't have that bx term. So I can go ahead, I can isolate my square. So let's add 35 to both sides, because the thing that's being squared is this x. That leaves us with 5x squared is equal to 35. Please, please, please be careful right here. I see that a lot of people, number one error is that we don't divide by 5 first. So make sure that you're definitely dividing by 5 first, leaving you with x squared is equal to 7. Now I can go ahead and I can take that square root. I'm going to separate it this time. So I'm going to take square root of x squared and the square root of 7. Now I can't simplify the square root of 7. That's as simple as it goes. So I'm going to go ahead, lock in, and watch this, is that we have x is equal to plus or minus the square root of 7. And I'm going to box this answer right here. And that's because, I'm going to check my work over here, is that I have 5 times square root of 7 squared minus 35. I'm going to check that that's equal to 0. So I have 5 times, and the square root of 7 squared, meaning that you take the square root of 7 times the square root of 7, just leaves us with 7. That's 35 minus 35. That's definitely 0 is equal to 0. And then I need to check this negative version. So I have 5 times the negative square root of 7 squared minus 35. And the negative times a negative, so this negative times a negative here is still going to give you a positive, meaning that that ends up with 5 times 7, and we just proved that before that definitely is 0 equals 0. So both of those answers work. Now, let's go ahead and let's try this out with our most complicated example of the day. So really time to lock in. Example 5, this has a whole bunch of key steps. So please make sure that you're following along. And if you have any questions later, feel free to write me an email or send me a message. We are gonna work through this one. I'm gonna point out all the key steps. Okay, so 2 times x plus 3 squared minus 50. If you will notice here, we have this x plus 3 squared. That's what needs to be isolated. Kind of think of it like that absolute value. So I'm going to use some inverse operations here, meaning that I need to add 50. You guys know that you start in the opposite order of PEMDAS. So we have 2 times x plus 3 squared, because that cancels out, is equal to 48. Now, tricky here. Please make sure that you are dividing by 2 because you need to make sure that you get that guy out of there. So you are left with x plus 3 squared is equal to 24. Okay, and now that you've completely isolated your square, meaning that everything on the left side is being squared. This whole x plus 3 is the thing that's being squared. Now you can go ahead and take the square root of both sides. And this is one of those key important parts. Be careful here. The square root of 24 can be broken down into 4 times 6, meaning that this simplifies to 2 root 6. So keep that in mind there, so that when I'm writing my answer, I'm going to have x plus 3 is equal to 2 root 6, but don't forget when you take the square root, you got to take the positive and the negative version of it. So you have x plus 3 is equal to plus or minus 2 root 6, and this is where that kind of key fourth step kicks in, is that you still have to solve for x. So you still have to subtract 3 from both sides. And here's one of those cool algebra tricks, is that I'm going to have 2 answers when I'm going to write them together. And I'm going to write x is equal to, keep your whole number out front. So we're going to go ahead and we're going to keep this negative 3 out front. And then I'm going to say plus or minus 2 square root 6. And here is my final answer. I'm going to go ahead, I'm going to box it, and then I'm going to tell you what this means. And this means that my 2 roots, so my 2 roots are going to be x is equal to negative 3 plus 2 square root 6, and x is equal to negative 3 minus 2 square root 6. And if you go ahead and you kind of plug these into a calculator, you're going to get some decimal approximations. So I'm going to go ahead and say that this first one is equal to about 1.899. All right, and then this next one, I'm going to say negative 3 minus 2 second square root 6 is approximately equal to negative 7.899. Okay, so again, these are my roots, meaning that this is where this parabola should cross the x-axis. And let's go ahead and let's kind of prove it to ourselves here. I'm going to pull up Desmos, and I'm going to get rid of this equation. I am going to have 2 times x plus 3 squared minus, and I have to put in 48 here because I have to set it equal to 0. And if we kind of remember those two numbers there, negative 7.899 and 1.899, those should be the same numbers that we had before. There they are. We did it. However, this over here, I'm going to even highlight it for us. This is how we want to go ahead and write our answer, is x is equal to negative 3 plus or minus 2 root 6. Okay, last example for the day, and that is just some housekeeping, is that we have 5x squared plus 10 is equal to 0. Okay, I don't have that middle term. This one should be pretty simple when I'm solving for it. I'm going to isolate that x squared. You guys are pros now, so you're first dividing by 5, so we get that x is equal to negative 2. Now that I'm isolating, I'm taking the square root of both sides, and oh no, I'm going to put this in red. For right now, there's no real solution because you cannot take the square root of a negative number. So my answer here is that I'm simply just going to go ahead, I'm going to box this, is no real solution, and that's what happens when you try to get the square root of a negative number. All right, you're all done. Go ahead and close this window, and if you have any questions, I'm happy to help.